Welcome everybody. What we're going to be doing today is we're going to be learning to use the cosine rule. The cosine rule, like the sine rule, is used with non-right triangles in order to find missing measurements. And in particular, what we're going to do is we're going to use the cosine rule in order to solve side, 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 and side angle side triangles. If you recall, those are two types of triangles that you cannot solve using the sine rule, and so this method combined with the sine rule, they can help you solve any triangle that you want to, right triangle or non-right triangle, it turns out. So first thing I actually want to do is I want to go through a derivation of the cosine rule, because the cosine rule itself is a complicated looking formula that you just have no chance of understanding unless you see where it comes from. You could use it, okay, but I want you to see where it comes from so you understand why it works. Alright, now here's the idea with the cosine rule. What we're trying to do is we're trying to come up with a way to relate the three side lengths of a non-right triangle. So I've got the right triangle ABC, and I can say that this is side B over here, of course, this is side C, and then this is side A down here. And at first there's really not anything we can do to relate those three sides because, well, the only way you can relate the three sides of a triangle that you know so far is with Pythagorean theorem. That only applies to right triangles, doesn't it? Now it turns out we are going to use Pythagorean theorem here, though. It's just that we have to create some right triangles in order for that to work out. And so, as we've done in other situations, what we're going to do is create two right triangles out of this non-right triangle by drawing an altitude, like so. And then when we draw that altitude, there's a couple of new things that I want to label. Let's just call that altitude h for height. And then that altitude divided the distance a down here into two different segments. And so I'm going to label those two different segments because the a goes all the way across. So let's call this little segment right here x. And then this little segment right here would be the rest of segment a. Or in other words, you could find its distance by doing a minus x. Okay, now here's what I'm going to do. I'm going to try to relate this side B to side C of the original triangle. And the way I'm going to do that is I'm going to compare them both to something that these two right triangles that are created have in common, which is the height. That's one of the sides of each of these right triangles, isn't it? So, using Pythagorean theorem, here's what I'm going to end up with. I can say that h squared, now I'm looking at the smaller right triangle right now, that's one of the legs, isn't it? H. And a leg squared always equals the square of the hypotenuse minus the square of the other leg. I can say in that triangle on the left that h squared is equal to b squared minus x squared, right? And if I'm looking at the triangle on the right, I can say that h squared is equal to c squared minus the difference of a and x squared. Like so. And now what I'm going to do is I'm going to go through and do a little bit of algebra. You see we got a's and b's and c's and x's. I would like there to not be any x's. We don't have to worry about the h squared, by the way. We've kind of gotten rid of it by substitution. I'm just going to focus on the b squared minus x squared equals c squared minus the difference of a and x squared. We're going to try to, again, to get the x out of this equation. We just want this formula that we're going to come up with to relate sides a, b, and c from the original triangle. All right. So that b squared minus x squared, not a lot we can do with that right now. But on the right side of this equation, I can go ahead and square that binomial. That will give me a squared minus 2ax plus x squared. And then I can go ahead and distribute that subtraction sign, right? So I'll still have b squared minus x squared. And that's going to equal c squared minus a squared plus 2ax minus x squared. Now remember, our goal at the moment is to try to get the x squared out of this equation, and that's working out nicely for us because you can see I've got a minus x squared on the left side of the equation, I've got a minus x squared on the right side of the equation. If I add x squared to both sides, that cancels it out. Now that doesn't get rid of the x's completely, though, does it? But it at least gets me down to this part of the formula where I can say that b squared is equal to c squared minus a squared plus 2ax. Alright, well, there's nothing algebraically that we're going to do within this single equation here in order to be able to get this x out of the equation and only have a's, b's, and c's. So we're going to use a little trick, and we're going to go back to the picture in order to get this, in order to create this little trick. If you'll look in this triangle where we have one of the sides where it's just x, I'm going to try to see if I can come up with an expression within this triangle to replace that x with. And the way I'm going to have to do that is I'm going to have to use a trig ratio. All right? Now, in this right triangle, if I look at angle C from the original triangle, right, x is the adjacent leg and b is the hypotenuse, I could say that the cosine of angle C is equal to x over b. And so that means that x equals b cosine C. And now what I can do is I can go over to the other equation and I can just replace x right here with b cosine C as such. B squared equals c squared minus a squared plus 2a, and then again I'm replacing the x with b cosine C. Now, we don't have this formula in its final form yet, but notice we successfully made an equation that relates the three sides of the original triangle, A, B, and C, and it just happens to have one of the angles from the original triangle as well. It turns out you need all those things in this equation. Last thing that I'm going to do is I'm going to try to get either A squared or B squared or C squared by itself, and there's only one of those that I can get by itself and have every variable kind of be positive. You'll see what I mean here in a second. What I'm going to do is I'm going to get the c squared by itself. Now, really, here's the reason I'm going to try to do that. You see the only angle in this picture, or in this equation, is angle C. And what I'd like to do is have it on the opposite side of the equation from side C. It's just the way it works out. So I'm going to add a squared to both sides. I'll get b squared plus a squared on the left side of the equation. I'm also going to subtract this term right here, 2ab cosine C, from both sides of the equation, and that's going to be equal to c squared. And that equation is the cosine rule. This one right here is. All right? And really, it's just a variation of Pythagorean theorem. Normally, you would say with a right triangle that c squared equals a squared plus b squared. Well, whenever we're working with the cosine rule, we're able to modify that slightly. If you take a squared plus b squared and you subtract 2ab cosine C from it, that's how you adjust for the fact that this is not a right triangle and how you compare it to the third side of the triangle. Okay, so there's a derivation of cosine rule. Hopefully that makes a little bit of sense. Let's kind of tell you how you're going to use cosine rule then. Okay? Two different triangles that you're going to have to solve with cosine rule. We said already a side angle side triangle and then a side 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 triangle. And in each instance, you're going to use kind of a different version of the formula, all right, at least for the first step. Whenever you're working with a side angle side triangle, the first thing you're always going to be able to find is the third side of the triangle. And when you are trying to find that, you just let the formula be exactly what we wrote a moment ago. You say it's c squared equals a squared plus b squared, right, Pythagorean theorem, and then minus 2ab cosine C. Now here's the important part that I really need to emphasize. I don't want you to think too much about the letters A, B, and C here. What I want you to notice here is that there's only one angle in this equation, and the angle that's in the equation, the side opposite to that is the side that's on the opposite side of the cosine rule equation. So I've got, I got the c squared right there on the opposite side of the equation from angle C. Just like side C over here is opposite angle C right there. So you have a side and its opposite angle on opposite sides of this equation. Okay, now it turns out that your formula booklet will have this equation, but also it will have this variation of the equation. Whenever you're trying to find a missing angle measure, it's often useful to have this term, the cosine of C, by itself. So algebraically, if you were to get the cosine of C by itself, this equation becomes the cosine of C is equal to a squared plus b squared minus c squared divided by 2ab. I'll leave it to you to do the algebra to get from here to here if you don't believe that that actually is the correct variation, but it is. All right, so we'll use the first one whenever we're trying to find a side length. We'll use the second version of the formula whenever we're trying to find an angle measure. Well, now let's go ahead and solve one of each of these types of triangles, starting with a side angle side triangle. And remember, a side angle side triangle is going to occur whenever you're given two side lengths and their included angle measure. Now I want to touch on sine rule for a moment. Remember, in order to use sine rule, you had to know at least one side and opposite angle pair. Well, I know two sides here, but I don't know either of their opposite angles. And I know one angle, but I don't know its opposite side. So sine rule, no good, at least at this stage of the problem. So we're going to use cosine rule here. Now let me just call this third side right here x. I don't necessarily want to use a's, b's, and c's at all. And then in order to use the cosine rule to find that missing side length, well, you're putting the side length that you're trying to find by itself, first of all. Okay? And so you just say that it equals the sum of the squares of the other two sides and then, so that's kind of like your c squared equals a squared plus b squared. Then you're going to subtract twice the products of your a and b, essentially, times the cosine of the angle that's across from the side that you're trying to find, 67 degrees. Okay? Now this is really just a calculator exercise from here, generally speaking, because if we're using cosine of 67 degrees, we want a number from this. We're not just going to leave it as an exact value. So you can say that x equals the square root of all of that stuff. All right? Now I'll simplify a little bit when I do this. 11 squared is 121. 14 squared is 196. 2 times 11 is 22. 22 times 14 is 308. And then cosine of 67 degrees. If you just type that into your calculator, it's going to tell you what that missing side length is. So go ahead. And so what we find then, to three significant figures, is that third side is about 14.0. Okay, excellent. Now, remember whenever you're solving a triangle, you want to find all the missing measurements? Well, we found one of the missing measurements so far, and we now know all three sides of the triangle. But we still got to try to find one of these two angle measures. Now, once you have used the cosine rule once, you have an option as to what you're going to do next. You can either use the cosine rule in order to find one of these two missing angle measures right here. All right? But the disadvantage to that, well, no, there's no disadvantage to that. It's just kind of a more complicated looking formula. But you also have the option now of using the sine rule because you know one side and its opposite angle pair. Now, there is a disadvantage to that in that sometimes you don't know whether the largest angle in a triangle is going to be obtuse or acute when you're using the sine rule, because the sine rule won't tell you if an angle is obtuse or acute. Now, in this particular instance, this was like 14.02. We happen to know that this 67 degree angle is the largest angle in the triangle because this is the longest side of the triangle, even if barely so, it is. However, I want to show you how to use the cosine rule to find missing angles. So although you would be safe to use the sine rule and assume that both of these angles are, well, this one specifically was the only other one that could have been the largest, you know that those are both acute angles. Let's see how you use the cosine rule to find them. Now, in this case then, let's say we call this angle, I don't know, I'll call that angle P or something like that. Okay? I'm going to write that the cosine of that angle equals, okay? And then the next thing I want to do is I'm going to look at the two sides that include that angle. That's kind of like my a squared plus b squared from the formula that you got written down. And I'm going to square them and add them together. So we'll say it's equal to x squared. Now, I had this value of x stored on my calculator. That's really this 14.0. And I want to use the stored value on my calculator to get this answer as accurate as possible. All right, so x squared plus 11 squared minus the side opposite the angle you're trying to find squared. So this 14 right here. All right, sorry, I covered up my 1, but that is a 14 right there. Divided by twice the product of your A and B, the two sides that form that angle. So twice x times 11. Okay, and again, I use my graphing calculator to do most of the work for me. I'm not going to bother simplifying this overly much, especially because I've got an approximate value for x that I don't really want to use. But at any rate, you're going to get that expression will tell you what the cosine of angle P is, and so P would be equal to the cosine inverse of that expression. There you go. I went ahead and simplified the 11 squared and the 14 squared. Now, I'm going to go and type this into the calculator, and everywhere I see an x, I'm just going to use answer because that's what I've got, but you could have stored that value in x and actually type in x right there. See what you get. All right, to 1 decimal places, which is what we'll typically do with unknown angle measures, we get about 66.8 degrees for that angle P. All right. Now, we have one more measurement that we've got to find to finish solving the triangle, and that, of course, is the other unknown angle measure. But you can easily find the other unknown angle measure simply by adding up the two that you do know and subtracting from 180. And whenever you do that, then you're going to find out that that third unknown angle is approximately 46.2 degrees. All right, there you go. So in a side angle side triangle, the first thing you do is use the cosine rule to find the third side length. And then you use either the cosine rule, which is preferred, or the sine rule in order to find the next missing angle. And finally use the triangle sum theorem, add two angles up and subtract from 180 to find the other angle measure. All right, that's a side angle side triangle. Let's wrap this video up by showing you how to solve a side-side-side triangle. Now with a side-side-side triangle, clearly you got to find an angle measure first. Let me call these angles X, Y, and Z. And what you're going to be able to do is, well, figure out any angle you want to, basically. But what I would suggest that you do is try to find the largest angle in the triangle first. Again, we don't want to have to really rely on the sine rule later on to find any angle measures because it can lie to us about whether an angle is obtuse or acute. But if we will use the cosine rule to find the largest angle, we'll automatically know if the largest angle in the triangle is acute or obtuse or possibly a right angle, right? And so how do we know which angle is the largest? Well, here's the longest side of the triangle, 29 centimeters. The largest angle always has to be across from the longest side. And so I'm going to find the measure of angle Y first. And I'll use the formula basically that we did a moment ago. You take the cosine of the angle that you're trying to find. And then you take the the sides of the triangle that form that angle, in this case the 22 and 27. You square them and add them together. Whoops. And then you subtract the opposite side from that angle squared. All right, so minus 29 squared. And then you divide by twice the product of the two sides that formed the angle, again, the 22 and the 27. So 2 times 22 times 27. And whenever you use that, then you're going to find that the y is equal to the cosine inverse of that value. All right, so just use your calculator and figure out what that is. Be careful with your use of parentheses. You want to make sure that you don't do this division right here until you've done all of this addition and all of this multiplication. All right, and so that tells me that angle Y is approximately 71.8 degrees to the nearest 1 decimal place. Okay, great. Let me label that on the triangle. Now, remember that we found the largest angle in the triangle because we found the one across from the longest side, and it happened to be acute. So that guarantees that this is an acute triangle, but even if it wasn't, we've already guaranteed that these two smaller angles in the triangle have to be acute. Now, in this case, to find the next missing angle measure, I'm going to use the sine rule just to kind of demonstrate how that works out for you. And I can trust the sine rule because I know these other angles are going to be acute. Let's say I want to find the measure of angle x next. Okay? Well, I can say then that the sine of x over its opposite side 27 is equal to the sine of y. Now, again, I'm going to have stored the value of this variable on my calculator, so I'm not going to type in 71.8. I'm going to use the more accurate answer that my calculator has stored. Sine of y over 29, right? And then the sine of x would be equal to 27 times the sine of y over 29. And so x, measure of angle x, is going to be equal to the sine inverse of 27 times the sine of y over 29. All right, figure that out, and we're almost done then. All right, you get about 62.2 degrees from that. I'll label that on the triangle. Whoops, didn't mean to cross through that side. And then we can add up angles x and y, subtract from 180 to find angle z, and we've got it. 46.1 degrees would be the measure of the final angle. Now you ought to know how to use the cosine rule in order to solve side angle side triangles and side triangles. Thanks for your attention. I know it's a little bit long here, but it's very good information that you've just gotten. Practice well. See ya.